These questions are taken from paper 2, section B, and they cover the flowchart and some code questions that are asked, such as to look for errors in a given piece of code, or to write very short algorithms. So let's have a look at the flowchart question first. So these are very common in the exam questions in section B. So you're presented with a flowchart, and then often you have to trace through, and potentially you may have to draw the flowchart from some text that you're given here. So we've got a bit of description here in terms of what the flowchart does. It takes it in a range of temperatures in Fahrenheit, and it's compared to the previous highest temperature, and if it's higher than the current highest, it replaces the previous highest temperature, and then it's converted to degrees Celsius. So let's have a look at this flowchart. So you can see it starts here. It assigns initially on its first run minus 100 to high F for Fahrenheit and high C for Celsius. Follow the arrow down. The next step is a parallelogram, which means it's an input-output. This first box, you'll notice, is a process box. It's just doing something. It's like assigning variable certain scores or states. So here we've done that. It's just a doing thing. And then we come to input or potentially output from this shape. But we're going to input a temperature, and these temperatures come from this list here. So we'll start on 68, then 46, and work our way through. The next is a question, essentially. It's a decision. It's got two pathways. It's a binary decision point. It's yes or no as it branches off. So the question is the temperature in Fahrenheit minus 1? Now, if you're wondering what that might mean, if you look over here, you'll see that minus 1 is the last input of this list, and that will give you a slight hint that that's going to be used to signify the end, as it were, because if you look at what happens, we come down the yes line and we output the highest temperature in Fahrenheit and Celsius, and then we end the flowchart. Whereas if it's not, we check if it's the highest and do what we've just described, and we come back and input again, and we're stuck in this loop until minus 1 takes us out of it. So let's work our way through. So as we said, the first thing we do is set these high F and C to minus 100. So let's do that now. And then what we'll do is we then come to the input. So we'll need to input the temperature. Now you can do this on the next line down, or as part of the flowchart. So we'll take in temperature, which is 68. Okay, and then we ask, is it minus 1? No. Is the temperature F greater than high F? Yes. As you can see, the initial states were minus 100, so that the first value would be set in all cases. Well, in all cases where it was more than minus 100 in terms of going up to 0 and above. Is the temperature the highest? Yes. So we then do this statement here, which we assign temperature F to high F. So let's do that, which is 48, which is 68. So that's 68, and then the next step is to work out it's in Celsius. So we'll have to do 68 minus 32, which leaves us with 36, and then we half that, dividing it by 2, which gives us 18. And then we can show, then we take in, then we come back up the loop and we can input the next temperature in Fahrenheit, which is, let's just tick that off, which is 46. So is 46 minus 1? No. Is temperature in Fahrenheit 46 greater than high? No. So we input the next temperature, which is going to be 50. So the state of these variables are going to be the same, so it's still 68, still 18, but the next one we're going to enter is 50, so let's do that and come to 50. Is it minus 1? No. Is it greater than? No. So it's still 68, still 18. Let's enter the next one, 86. So we can see this is going to be higher. 86 is higher, so we assign that to the highest, and then we work out what that is in Celsius, which is going to be 27. Come back up the loop and enter the next one, which is 65. 65 isn't, of course, we stay with 86, 27, and then we enter 50 again. It's not more than 86, so it's still 86, the state of these variables, and 27, and we enter the new, come back up the loop again to input the next one, which is 40. Again, it's not higher than that, so still 86 and 27, and we enter 30. Now at this point, of course, is where we can start to see something's going to happen in a second. 30 isn't, so it's still 86, 27 and 30. And then we're going to enter -1. We come up to -1. Is it -1? Yes, and then we'll come back to this here, which is the output. We'll output the highest temperature is, and this will obviously output a string, so the highest temp, so maybe it's best to probably write it all out, the highest temperature is, and then we fill in those variables, so 86, which is the contents of that variable, high F, Fahrenheit, and then 27, so F, I'll just put F for shorthand, comma, and then the output will be the 27 Celsius. 27 Celsius. So obviously write the whole words out to show you know and you understand how it would fully be written out. I'm just doing that for speed. And that's the kind of method you'll go through in terms of tracing most flowcharts. Now let's look at another question from here, which is another fairly common question, which is looking at errors in a piece of code that you're given, usually about sort of 8, 9, 10 lines of code. Nothing complicated. So we look at this one, we can see, we need to study it and look at it initially. But obviously what this is doing is setting total and counter variables. It's going to print to say what we've got to do, so it's saying enter 50 numbers, one at a time. We've then got a repeat loop here, where we ask the user to enter a number, take that number in, store it, and then we do something, like add it to a total or something, it looks like, and then we increase something by 1, that looks like it should be sort of like some sort of counter variable, and then we repeat until this counter is 50. So it's essentially taking a number, increase a counter, is that counter 50? No, so increase, and then move round and around until that counter is 50. So essentially we're going to take in 50 numbers and add them together or something similar, it seems like, and then we're going to, once we've taken in all those numbers, we're going to work out some kind of average and then print the average. But it looks very like there's some issues here. So the first issue I can see is line 2. So the problem with that is the counter is already set to 50. So as soon as you come down to this loop, you'll do the loop initially because the condition's at the end here. You'll print the number, input the number, but of course it says until counter is 50, where it already is 50. So you'll come down to line 10 and then at line 11 and you're done. So that's not going to work, is it, as intended. So counter should be set to 0. So it should be counter equals 0 for that particular one. The next one is line 7, where it's just purposely put the wrong way around in terms of adding to the total. It should be total, something like total, I'll put it out the long way, total equals total plus the number. So every time we go through the loop, whatever the number input, we add it to the total. We keep accumulating the numbers until we finished after 50. So it'll be like, first one might be 7, then it might be 3, so then it'll be then 10. We enter, say, 4, then it's 14, the total. Let's say on the fourth pass we enter 6, then the total is 20, and so on. So we keep increasing the number. The next error is on line 8. It says number equals number plus 1. That, of course, should be the counter increasing, so that it starts at 0, goes through 1, 2, 3, 4, all the way up to 50, and then when it gets to 50, that's our condition to exit the loop. So we can clearly see that number equals number plus 1 should be counter equals counter plus 1. That's the long way of doing it. Now, the next one is, you can see line 10. That's not how you work out an average. You need to divide it by the number, depending on what average we're going to get, but we're going to get the mean average. So we're going to do, it should be average equals the total after 50 passes divided by 50 or counter. So if we do it, the best practice would be to divide it by counter, because obviously then it makes the code flexible in terms of if we were to change the number of times we would do it rather than hard code it. Let's look at one more question. This question is looking at asking some questions here. So the first one is, describe the purpose of each statement in this algorithm. A couple of marks. So if we look at the first line here, we can always write lines here. So the first one here, the purpose of that is to loop 300 times. It's a for loop. There's no conditions. It will loop 300 times. You might put, from 1 to 300, because it sets I to 1. So that's what it does. You could extrapolate a bit more on that. Second line, input name and bracket I. So it says basically that the values, stored. It's basically, when you see the square bracket, you can see that that is to do with an array. So at position I, so whatever I is in the loop. So it's going to be to the values input in an array at position I, which will change, of course, as you go through the loop. And obviously that's the job of number 3, which is the next I, is to increment I. So if we use the technical term, to increase or increment I. So now it becomes 2, 3, 4, 5, 6, 7, 8, and so on. So hopefully that makes sense. So you've taken an input and store it at position 1. Increase I, so I becomes 2. Then you input a value and you store that at an array called name. So that's what the array is called. And you store it at that position and so on. So you're basically going to be taking your numbers and storing them in a list. B. Identify using pseudocode another loop structure that the algorithm in part A could have used. So of course you could have used the repeat until or the while. So you do the condition first or after. So you could have done while. That's what it's looking for. You could use the while, or repeat is the other one you need to be aware of. So you repeat some code until. C. 3 marks. Write an algorithm using pseudocode, or Python would be fine, to input a number between 0 and 100 inclusive. So this has got no loops. This is just a simple prompt input if statement to check it's between 2 values. And it was outside the range, print and output. So let's look at that structure. So you basically want to output, so line 1, output something like, please enter set a number between 0 and 100. A number between 0 and 100. Don't forget the quotation marks. Second line would be then to input that a number, as in number equals input. You can do it that way around in terms of pseudocode, but basically input a number. So you're taking a value and you store that value in the variable number, and then you can do if that number, then we're going to do some validation here. We're going to do a range check, is less than 0 or number is greater than 100. Then, so obviously in Python you can just do the colons, but I'll write it out in pseudocode. Let's actually indent that slightly. Then, what we're going to do if it is, then so we're going to output not in range, not in required, some kind of error message, not in required range. And then of course in pseudocode you're supposed to kind of close the for if with end if, for with end for, while with end while. It's just closing it formally. So end if. So that links together, and that's it, just on one pass.